Hi, this is Miss Hall, and in this video we're going to review converting between decimal, binary, and hexadecimal numbering systems. Before we get into the Delta Math modules, let's review what these numbering systems look like, beginning with decimal. Decimal is the one you're most familiar with. It's the one you use in math class. In decimal, it is base 10. The numbering system is a base 10 numbering system. So the first place value represents 10 to the 0, then 10 to the first, then 10 to the second. If we perform that operation, the first place value represents the ones place, and then the tens place, and then the hundreds place. So this is why when we have a number like 3, 4, 1, what we're actually doing is we're saying, so there are 3 times 100, there are 3 hundreds plus 4 tens plus 1 1. Okay, and this is 341. You notice that each place value can hold the numbers 0 through 9. So these represent 0 through 9, so they can hold 10 digits, 0 through 9. Once you get higher than 9, you spill over into the next place value. So this is a review of decimal. Now, let's do binary. In binary, that base number system is 2. So the place values are going to be 2 to the 0, 2 to the first, 2 to the second, and so on, which 2 to the 0 is 1, 2 to the first is 2, 2 squared is 4. So if I have a number like 1, 0, 1 in binary, and I'm going to convert it to decimal, what I'm going to do is I'm going to say, well, I take 1 times the place value, which is 4, plus 0 times the place value, which is 2, plus 1 times the place value, which is 1. And this would be 4 plus 1, which is 5. So that would represent 5 in our decimal number system. Now here, there can only be 2 digits per place value. It's a base 2 number system, and the digits are 0 through 1. So each place is either 0 or 1. And finally, we have a hexadecimal number system. Hexadecimal is base 16. So it's 16 to the 0, 16 to the first, 16 squared, and so on. Which means this is the ones place, this is the 16s place, this is the 256 place. Now let me go here. That means we need to represent 16 digits in each place value. We need to represent the digits 0 through 15. But we don't have, like if we were to write 15, that takes up 2 places. So we need a way of representing 15 that's a single character long. And that's where our alphabet comes into play. So let me list at the top. So each place value in hexadecimal could be 0, a 1, a 2, a 3, a 4, a 5, a 6, a 7, an 8, a 9. If you want to represent 10, you put an A. So A represents 10, B represents 11, C represents 12, D represents 13, E represents 14, and F represents 15. So that's why in hexadecimal, you can get a number like 0, let's do 1D. Looks like I spelled old. And so what I'm going to do is I'm going to take 0 times the place value, which is 256, plus 1 times the place value, which is 16, plus D, and I need to convert that into decimal, so that's 13 times the place value of 1. So what I really have here is 16 plus 13, which is 29. Let's do an example from the skill Convert Binary to Decimal. So let's convert the binary value 110010 base 2 into decimal. So for myself, I need to put the place values of binary, and I need 1, 2, 3, 4, 5, 6. So I need 1, 2, 3, 4, 5, 6. I know that all numbering systems start to the 0 power and go up. So it is 2 to the 0 all the way to 2 to the 5th, which is 1, 2, 4, 8, 16, 32. Now let me fill in. It was 1, 1, 0, 0, 1, 0. So I have 1 times 32, which is 32, plus 1 times 16, which is 16, plus 1 times 2. So 32 plus 16 is 48, plus 2 is 50. The answer here is 50. Now in convert decimal to binary, we're going to go the other way. We're going to convert the decimal value of 94 into binary. Like always, I need to set up my place values. 2 to the 0 is 1, 2, 4, 8, 16, 32, 64. Double of 64 is 128. That is higher than 94, so I know I don't need to go that high. Now what I'm going to be doing is I'm going to say, okay, so I have 94. I know 64. I can take that away from 94. So what I'm going to do, I'm going to say, okay, minus 64 is 30. So I need to represent 30 more, which means 32 is too high, so I need a 0 in that place value. And then the 16 place value, I can subtract 16. I'm left with 14. I can subtract 8, so I need to turn on or set 8 to 1, minus 8, and I have 6. I need to use 4, and I'm left with 2. When I subtract 2, I am left with 0, so I don't need anything more. And this should be the value of 94. If I wanted to double check my work, I could take 64 plus 16 plus 8 plus 4 plus 2 and double check that that represents 94. And the final skill in this grouping is converting decimal to hexadecimal and binary. Convert the decimal value 155 into hexadecimal and also into binary. Let's begin by hexadecimal. So in hexadecimal, the place values are going to go 16 to the 0, which is 1, 16 to the first, which is 16, 16 squared, which is 256. And 256 is higher than 155, so we will not need that place value. Now we got to figure out how many 16s are there in 155. So the math I'm going to do is I'm going to take 155 divided by 16, and you get 9 something. So I know I need 9 16s. Let's calculate. 9 times 16 is 144. So let me take, my goal is 155 minus, I've already represented 144. I need to represent 11 in the ones place value. Can't just put 11 in there, that's 2 digits. So I've got to think back to, okay, so in binary after 9, A represents 10, B represents 11. So the answer here is 9. B is the hexadecimal equivalent of 155 in decimal. I can put that right here. So the answer here is 9B. Now for binary, I need more place values. It's base 2. So the first place is the 1s, then the 2s, 4s, 8s, 16s, 32s, 64s, 128, and then it'll be 256, which is higher than 155, so I don't need that place value. Let's do my math. So I can take 128 out of 155. So let's do 155 minus 128 is, this will be 7, and this will be 27. So So 64 is too high, 32 is too high, 16 is not. So let me turn on that 16 place. Subtract 16, I have 11 left. 8 is too high for 11. Oh no, 8 is not too high for 11. I do want 8. Subtract 8, I am left with 3. 4 is too high to represent 3, but then I need to turn on 2 and 1. And so my binary equivalent of 155 in decimal is 100111011.